Hello everyone, welcome to day three of graph theory. We're going to do a little bit more with Dijkstra's method, which is where we use Dijkstra's algorithm to find the shortest path through a network graph, which is something that looks like this, right? So this is a network graph filled with vertices and edges, and we see the weights assigned to the edges representing distances or times or whatever. So in this case, these represent distances, and our goal is to find the shortest path from Royton to Aston. Okay, so we're going from Royton to Aston here. So recall from yesterday, the first thing that we did was we marked the start and the end point, right? So Royton is the starting point and Aston was the end. Okay, and we always mark the end with a 0. So we always started off there. Okay. All right, now, so once we have marked our end, we start at the end and then we analyze every edge coming into the end vertice there. So I can see two edges coming in. I got the 3 and the 7, so I'm going to go to Mosley here, and I'm going to mark that with a 3 because it has a distance of 3 from the end. Same thing with Duncanfield. I'm going to come up here to Duncanfield. It has a distance of 7 from the end. And then I like to mark where I came from, right? So I came from Aston, so I'm just going to put an A there for Aston on both of those. And this is so I can trace my path back later. All right, now once we've analyzed all of the edges leading into that vertex, I like to mark it as visited so we don't try to analyze back to that vertex again. So I'm going to circle that just to indicate that it has been visited. Then we look at our vertices, right? So I'm going to look at Mosley and Duncanfield because I've calculated the distance for those two, right? And I go to the one that is the shortest. I always go to the one that's the shortest first. All right, so we're going to go to Mosley because it had a distance from the end of 3. Right, and then I see two edges coming into Mosley. So I'm going to do this one first. So we'll do 3 plus 3. So we could get to Duncanfield in a distance of 6, which is shorter than the current distance that I have. So I'm going to replace it. So I'm going to put a 6 right here, and I'm going to put an M for Mosley, and I'm going to cross out this path to Duncanfield. All right, so what just happened there, right? We had a distance, or we had a path to Duncanfield going from Aston. It had a distance of 7. But I can get there quicker if I go to Mosley first and then Mosley to Duncanfield, right? Because 3 and 3 give me 6. So it would not make sense to take this path to Duncanfield. So that's why we cross it off. All right, let me go down here. We got one more edge, right? So we got Mosley to Lees, right? So 3 plus 6 is 9. So I'm going to mark Lees with a distance of 9 from the end, and I'm going to put an M next to it. Okay, and now Mosley has been visited. We're done analyzing that one. So again, I take a look at my vertices that I have marked here. So we have a 6, we have a 9. So I'm going to go up here to the 6, and I'm going to do the same thing, right? So this first edge goes back to a city that's been visited. This second edge goes back to a city that's been visited. And this one goes to Shaw. So we're going to have 6 plus 12, which is 18. So it's telling me that I can get to Shaw in 18 miles. I don't know if they gave me miles. So in 18 miles, and I'm coming from Duncanfield, so I'll put a D on that one. Okay. And then we got one more edge over here, so we got Duncanfield to Chatterton, so I can get to Chatterton in 12, right? 6 plus 6 is 12. So I'll put a 12 there and put a D next to it. And Duncanfield has been visited. So then again, I look at my vertices, right? So 9 is currently the shortest one, right? I've got 3 edges coming out of Lees. This one goes back to a visited city. This one goes up to Chatterton, right? So I got 9 plus 5, which is 14. Well, the other route was quicker, so I'm not going to replace that one. And then 9 plus 3 here is 12. So I can get to Shaw in 12 miles if I go through Lees. So I'll cross out this one. And now Lees has been visited. I've analyzed all the edges leading into Lees. Right. So I do another analysis here. I look at my two vertices that I have marked. They're both at 12. All right. So in this instance, it doesn't matter which one you go to first. You can go to either one. Really doesn't matter. So let's do Chatterton first. Okay. So we'll do Chatterton. I look at there's 3 edges leading into Chatterton. So one goes back to a visited city. This one goes back to a visited city. This one's going to get us to Royton, which is where we want to go. All right, so I got 12 plus 3, so I can get to Royton in 15 miles. if I go through Chatterton. So I'll put a C next to that one. Okay, and that one is done. All right, so again, I look, I got 15 and I got 12. So let's go back here to Shaw real quick. All right, Shaw's got 3 edges. This one goes back to a visited city. This one goes back to a visited city. And then we go over here to Royton. So I go 12 plus 4, which is 16. Well, that's longer than the route that I already have. Right, so I don't really need that route coming through Shaw. So we are done. So we have figured out that we can get to Royton in 15 miles. All right, now let's trace our route back. All right, so we start in Royton, so I'm just going to abbreviate that with an R, and then it tells us to go to Chatterton. All right, and then from Chatterton, we go to Duncanfield. And then from Duncanfield, it tells us to go to Mossley. And then from Mossley, it tells us to go to Aston. So here's our route, and it's got a distance of 15 miles. Right, and something else that I like to do, I like to highlight the route, just so I can physically see it here on the paper. Right, so we're going from Royton to Chatterton, then from Chatterton to Duncanfield, then from Duncanfield down to Mossley, and then from Mossley to Aston. So there's our shortest route. Okay. All right, now we're going to do another one. All right, but this one's going to be a little bit harder. All right, so you notice that I have these marked, right? So that was an easy one. This one is what I would consider to be a medium problem, all right? You definitely want to make sure that you can take a problem like this and do at least a medium level one. All right, so make sure you watch me through this one. Here we go. All right, so it says find the shortest path from A to J. No problem. So here's our start. All right, it says from A to J. So J is our end. And I'll mark that with my 0. There we go. And then we'll start the algorithm, right? We're going to analyze all the edges leading into J. So I'm going to come up here to I. All right, I is 21 away. All right, 0 plus 21 is 21. 0 plus 56 is 56. And this is coming from J. J is done. All right, now we go to the shortest one, which is the 21. Okay, one edge goes back to J, so I don't want to do that one. I do this one, 21 plus 29, that is 50, right? And that's shorter, so I'm going to replace it. Gone. All right, and then we go over here. So we got 21 plus 108. 21 plus 108. So I can get to E in 129 through I. Okay. I is done. All right, again, look at your vertices. Which one's shorter? Down here at H. So we'll make H our current. And then we've got 1, 2, 3, 4 edges coming out of H. These two lead back to visited cities, so we only have to analyze these two. So I got 50 plus 40, which takes me to G at 90, and I'll put an H next to that. And then I got to go H to F here, so 50 plus 62 is 112 through H. All right, H is done. All right, look at those vertices again. So we got 129, 90, and 12. So I'm going to go to H here. So H has a distance of 90, and we've got 1, 2, 3 edges coming into it. One goes back to a visited city. So it's just this one and this one that I got to do. All right, so if I do 90 plus 46, well, that's 136. So that is longer than what I currently have. So I'm not going to do that one. All right, so then I come down here, we do 90 plus 20, well that's 110. So I'm going to replace, right? This is shorter, 110 is shorter than the 112. So I'll say 110 coming through G. Now G is done. Okay, so we got 112, we got 129, I'm sorry, the 112 got crossed out. So we got 110 and 129. So we're going to go to the 110, and I'm looking at all of these edges. I got 1, 2, 3, 4, 5, 6 edges. 2 of them go back to visited cities. So I've got 4 that I got to do in this one. So let's do this one first. 110 plus 90 gives me a 200. And that's coming from F. And I got to do 110 plus 112. So that's going to give me 222. And then I got to do 110 plus 208. So that'll be 318. And then I got one more here. So I got 110 plus 16. And 110 plus 16 is 126. That is shorter than the 129 I have. So I'm going to replace that with my 126 coming from F. All right. We got so that one is now visited. All right, we got our 3. So right now the 126 is the shortest. I've got 4 edges. So that one goes back to a visited city, back to a visited, back to a visited. So we only got 1 edge here. So 126 plus 110 is 126 plus 110 is 236. So I definitely want that one coming from E. There we go. That was shorter than the 318. All right, so E is visited. All right, making our way across this map for sure. So we got 236, 222, and 200. Right now 200 is the shortest, so let's look at that one. We've got 3 edges. One goes back to a visited city. So here we go. So we got this one. So if I do 200 plus 20, well, that's 220. So that's shorter. Cross that one out. Then we've got 200 plus 96 to get to A. So that completes a path, but I don't know if it's the shortest one. I now know that I can get to A in 316 going through C, but I don't know if that's the shortest path yet. Okay, so I'm going to circle C, look at my vertices. I got 316, 220, and 236. So the 220 is currently the shortest one. It's got 4 edges. These 2 go back to visited cities. This one, let's see, so we got 220 plus 18. That would be 238. That's longer than what I have here. And then 220 plus 78 would give me 298. So that is shorter than the 316 if I go through D. Okay. D is visited. All right, let's see what we got left. We got 236, 298. Okay, so the 236, 298, let's see what happens here. We've got 1, 2, 3, 4 edges coming off the 236. These 3 all lead back to visited city, so it's really just this one that we got to look at. If I do 236 plus 56, well, that's 292. So that's shorter. Going through B. Okay. So I think we are done. It was a long one. All right, so there we go. So we got our shortest route. We just have to write it out now. So we start at A. All right, and when I go to A, it tells me to go to B. All right, so we would go up here. So I'm going to write down B. Once we're at B, it tells me to go to E. All right, so E is, where is E? Here's E. Okay, so once I'm at E, it tells me to go to F. Okay, so go to F. F is down here. And once I'm at F, it tells me to go to G. Right down at G. And let's go to G. Where's G? G's here. All right, so now I'm at G. G tells me to go to H. H is down here. So H tells me to go to I. That's up here. And then I tells me to go back to J. So there's my path, and its distance was 292. And let me go ahead and highlight that path. Okay, so we went from A to B, B to E, and then E to F. Where's F? All right, F to G. G to H, H to I, and I to J. There you go. So now you can really see that path through the network graph. All right. All right, guys. So that again, just two more examples of Dijkstra's algorithm there. Hopefully those are helpful for you, just to see me work through those and highlight those paths and kind of think about why I leave those letters there. If you're reading the book is not going to tell you to leave these letters next to the numbers, and I'll tell you they are really helpful at the end when you're trying to trace your route back. All right. So let's take a look at the hard one real quick. And I'm not going to actually do the hard one for you, all right? But I'm going to give you the answer. All right, these two on the second page are here if you really want to challenge yourself with this Dijkstra's algorithm. So here's the answer. So if you do decide to do it, here's the answer. All right, you got A, E, B, F, G, H, J, K, M, N. Right, and that's to get from A to N, and it had a distance of 26. All right, so there's your correct answer for that one. And this one would be considered a hard one. There's a lot of different paths to analyze there. All right, and then we'll come down here. This is the super hard one. So if you're a glutton for punishment, this one is an interesting problem. It's analyzing a race. Okay, so you have three racers, John, Lee, and Safraz. They start at these 3 points, A, B, and C, and they race through the network graph to get to the finish point here. And you can actually use Dijkstra's algorithm to figure out who is going to win and how long it's going to take them to get to the finish line. All right, so for this one, as it turns out, Safraz wins. Safraz wins in 90 seconds. So the path that he takes him 90 seconds, and here's the path that he takes for the win. C, F, E, H, G, K, M, N, N. There we go. So that's the path that he takes, and I'll highlight that for you so you can see it. Okay, so Safraz was starting at point C, right? So he starts at point C. Go down a little bit here. All right, so he goes from C to F to E, right, and then E to H, and then he goes to G, and then he goes to K. Then he goes to M, and he goes to N. So that was his winning path there. All right. So like I said, if you want to try that problem, do your Dijkstra's algorithm, see if you get the same result as I did. That way you know you're doing it right. It is a really good practice problem. It is kind of long though. All right. All right, guys. Good luck. Make sure you ask me questions in the Zoom chat if you got them. Otherwise, have a great day.